So here we look at another way of making nitriles. This method is through a dehydration reaction, and specifically a dehydration of an amide. Now, in this reaction, we start with an amide, and specifically one with an NH2 group on it. It needs to be an NH2 group because, as you'll see during the mechanism of this reaction, we will actually um, lose these hydrogens during the reaction. But through the addition of thionyl chloride and heat, refluxing in a solvent like benzene, we can lose the oxygen of the carbonyl as well as these two hydrogens on nitrogen, thus losing water in total, and making a nitrile where the nitrile is attached to whatever this R group over here is. So this reaction works in the following way. So the sulfur of thionyl chloride is reactive. It's bonded to three highly electronegative elements, two chlorines and an oxygen. The mechanism starts by the nitrogen adding in its lone pair, which allows for these pi electrons to attack sulfur. As a result, the sulfur-oxygen pi electrons get pushed up onto oxygen. Similarly to the way that pi electrons from a carbonyl move up onto the oxygen when attacked by a nucleophile. Giving us this intermediate. And in this intermediate, the oxygen adds its electrons back in, kicks out a chlorine. And then that nitrogen can lose a proton. All of this has been setting up so that the oxygen has a good leaving group on it, and so that it can be the leaving group in our final step, the elimination, where chloride ion can come in, remove this hydrogen off the nitrogen, electrons shift over, form the triple bond, and we lose our leaving group. And this reaction can be done with any variety of R groups on that initial amide to allow us to make a wide variety of different types of nitriles.